So following on from some of our earlier videos, we wanted to minimize the amount of material needed to produce this box here. You could also solve this problem by using implicit differentiation. So start out with your volume here. The amount of material needed is given by this. Okay, so now look at this. Look at these two equations here. We're going to implicitly differentiate this. We're going to implicitly differentiate this, and then we can also solve this problem by using implicit differentiation. So starting with these two here, differentiate this, implicitly differentiate this. So remember, the volume is fixed. So it's like a constant here. It's like 700 centimeters cubed or 500. This volume here, once a problem has been set, this V here is fixed. Okay, it's a constant. So when you differentiate it, it will give you 0. Now, when you come to differentiate this, you've got to use a product rule. So here you've got one thing multiplying another thing. And remember, if you look at your box here, this here is your x, this here is your y, and we are varying x. We are changing x back and forth. We are sliding x back and forth, and the y here reacts to our variation. When we slide it back and forth, the y reacts to it, meaning y is really a function of x. Y is really a function of x. So that means you can think of this here as being y is a function of x here. So when you differentiate this here, so you've got to use a product rule here. So when you differentiate this, it will give you this. So the product rule is sorry, hang on, I'm talking gibberish. Sorry. When you differentiate this, it will give you this, not this. Sorry. So when you differentiate this here, sorry, hang on. Let's start again. Starting from here. Use implicit differentiation. That will then take you to this. So when you differentiate this, it will give you 0 because v is a constant once the problem has been set. Now you've got to use a product rule now. So it's going to be this times this. So the product rule is differentiate this, leave this the same. So differentiating this will give you this, leave this the same. That will then give you this, and then leave this the same, and then differentiate this. When you differentiate it, it will give you 1, but then because y is a function of x, you've got to stick in y prime. Okay, so that will then give you this, and then rearrange it to make y prime the subject here. That will then give you this. Tidy up, y prime equals this. Okay, so hang on. So we started out with these two here. We've just done this one. Now we've got to differentiate this. Okay, so hang on. So starting out with A here. So now you've got to remember our A. So look at our box here. This is x, and this here is y. Okay, this here is y. Remember that we are varying x. So y reacts to our x. So meaning y is a function of x. Now, if you look at A here, A is the amount of material needed to produce this box. As you vary the x here, you are also varying the amount of material needed to make the box. Meaning, as you vary x, A reacts to you changing the x. So really, A is also a function of x. Okay, v wasn't a function of x because v is always fixed. V is fixed. V doesn't really care as you vary the x. Now, as you vary the x, y reacts to it, and the area also reacts to you changing the x. Okay, so A is a function of x. So when you differentiate this, it will be or you can think of it as a when you differentiate this, it will then give you this. And then differentiate this, it will give you this. So here you've got a product. You've got to use a product rule here. It will then give you this. Okay. So that will, if you differentiate this, it will then give you this. But don't forget, earlier we've got y prime. Earlier y prime was this. Y prime here is this. So we can put this into here. Okay, put it into here, and then blah blah blah. That will then give you this, and then tidy up, blah blah blah. That will then give you this. Okay, so dA by dx is given by this. Now we want to find out when dA by dx. Well, this is a here, this is x here. It gave us a graph looking like this. We want to know when the gradient will be 0. So set this thing to be 0. Okay, so that will then take you to here, and then tidy it up. It will then give you this. See, same answer as in the previous video. If you have your box here to produce to minimize the amount of material needed to make your box, just make y half the size. Sorry, just make y half the size of, or make y half the size of x. Okay, same as this is the same result as in our previous video. Okay.